Everyone, thank you so much for joining us today. We're just having some folks filter in from the waiting room. But I'm gonna go ahead and get us started right on time. And if people join as they come in, they can catch up. So aloha, everyone. Thank you so much for joining us today for this seminar on SeaLevel Rise, tidal flooding, and cesspools. My name is Katie Hinson, and I'm an extension agent specializing in coastal resilience with the University of Hawaii Sea Grant College program. And we are bringing you this seminar today as part of an ongoing project that Hawaii Sea Grant leads called the Hawaii and Pacific Islands King Tides Project. We have a really great lineup of speakers for you today.
Join the meeting.
Including Dr. Phil Thompson, who's an assistant professor in the Department of Oceanography at the University of Hawaii at Monmouth, and the director of the UH SeaLevel. He'll be presenting on his research illustrating the connections between sea level rise and tidal flooding in the Hawaiian Islands.
Now you're muted too, Katie.
Oh my goodness, did you guys not hear any of that?
You got to Shelley, I think.
Okay, gotcha. All right, so Dr. Shelley Habel, the Coastal Lands Program Coordinator with Hawaii Sea Grant and the Department of Lands and Natural Resources Office for Conservation and Coastal Lands, will be speaking on her research discussing the impacts of tidal flooding and projected sea level rise on cesspools in urban Honolulu. And then we'll hear from Yoko Schneider, who is the Gordon Grau Fellow with Hawaii Sea Grant and a project coordinator at VI, the Wastewater Alternatives and Innovations. And he'll be discussing some of the opportunities and resources for replacing cesspools with alternative wastewater treatment methods. So we're going to have ample time for questions between each of the speaker presentations, but we ask folks to please enter their questions into the chat box just because of the number of people we have joining today, and we'll be able to feed those to the speakers to answer. We also want to advise everyone that we will be recording the webinar today in case you have any colleagues or friends that you would like to share it with afterwards. Before we hear from our speakers, I would like to speak a little bit about the Hawaii and Pacific Islands King Tides Project, which is a community science and education initiative that this event is part of. This project uses crowdsourced photographs and observations to document the impact of the highest high tides of the year, also known as king tides, along our coastlines throughout the Pacific region. And the reason we're interested in documenting these extreme high tide events is because they allow us to understand what our shorelines and low-lying areas may look like with a future of sea level rise. So we like to say that through our project, we ask community scientists to snap the shore and see the future. This project utilizes technology that most of us carry with us everywhere, our smartphones. We have an online platform that allows you to easily and quickly upload photographs of tidal flooding impacts and fill in additional information like the GPS coordinates, the time, the date that corresponds to the image you're submitting. The project also taps into our collective local knowledge of our coastlines. We're working with community scientists like many of the people on this call who have been living, fishing, surfing, paddling, in the coastlines that they're photographing for years, if not decades or generations. And this collective experience and understanding translates not only into observations, but into local ideas for adaptation. So we ask our community scientists to enter their personal observations and knowledge of the place that they are photographing to help lend additional context to the impacts being documented. So this is our pitch to ask you to please go out and take photographs as part of our upcoming 2021 photo survey in the Hawaiian Islands. The King Tides will be happening on July 22nd and 23rd, and again on August 19th and 20th. And you can go to our website to find more information as well as peak tide times for specific locations across the Hawaiian Islands. And this is our website, pacificislandskingtides.org. So you can use this URL to access our online photo submission platform, to find more information about the project. And if you are one of the folks joining us from another part of the Pacific beyond the Hawaiian Islands, you can also sign up for our listserv at this website to get notifications of upcoming king tides and photo surveys in your place. And Maya has helpfully entered the website into the chat in case you're frantically trying to note it down. So through this project, community scientists have contributed more than 3,000 photographs of king tide impacts across the Pacific. And all of these photos are available in a publicly accessible database that is often used by educators, policymakers, and researchers to better understand and communicate the anticipated local impacts of sea level rise. And you can find those 3,000 photographs at that same website. What I personally really love about this project is that it allows us to take an issue like global sea level rise that can feel very big and abstract and make it tangible and place-based and relevant to the resources and places that we love. So these images really can help to spark conversation about how we can take collective action to build resilience, capacity, and adapt locally. And the conversation that we are going to be having together today about cesspools is tackling just one of the many pieces of that adaptation puzzle. So as I transition us on to our speakers, I do want to take a moment to just acknowledge that sea level rise and cesspools are a complex problem with significant environmental justice implications. Sea Grant is not a regulatory institution, and our intention here today is to provide space to share knowledge and work towards collective options for caring for our islands. We unfortunately won't be able to cover the full complexities of these topics today, but we really hope that our time here together can help us all to empower ourselves with more information and to spur future conversations that contribute to long-term solutions. So with that being said, I'm going to go ahead and introduce our first speaker, or allow him the opportunity to introduce himself more thoroughly, Dr. Phil Thompson.
Okay, thanks, Katie. Yeah, so I'm a professor in oceanography at the University of Hawaii, and my research focuses on sea level rise and variability, and increasingly into the impacts of that change. So what I'm going to talk about today is sort of the ocean side of it, the oceanography side of flooding, and then you'll hear from our subsequent speakers, and they'll tell you more about the impacts. So what I want to define first is what is high tide flooding, and this is how we refer to the types of events that will impact the cesspools and other types of impacts you may have seen around our state already. So what we mean is flooding at or near high tide. It's pretty obvious. It's called high tide flooding. But what's perhaps less obvious is that we're not talking about wind and waves. So those are separate issues. Wind and waves can make it worse for sure, but they're not necessarily the primary cause. And I'll tell you more about what causes this in just a moment. So individual events, when we talk about high tide flooding, we're talking about things that are sort of on the minor or nuisance level kind of impact, but that's only for one event. And this is a really important distinction because sometimes it's difficult to communicate that when we talk about high tide flooding, yeah, it's standing water in a road. It's not the same sort of impact on an individual event as it would be with a hurricane, right? And the sort of storm surge and large flooding that you would expect from a true extreme weather event. But when you accumulate many of these small events over some protracted period, the impact really starts to add up. You'll hear more about this from Shelley about how you might have one high tide event that causes a little bit of seepage from a cesspool. On an individual basis, perhaps that event does not cause that great of an impact. But when you have many of these over a period of time, and as the increasing frequency of these continues, then we could start to have issues. So yeah, so the impacts on any individual event, minor, but added up over many, they can add up to quite an important impact. Okay, next slide. Okay, so then what causes high tide flooding? If we're not talking about wind and waves, what are we talking about? Well, there are a lot of things that are happening in the ocean that cause the water level to change. So I guess I can't point. when I was like looking at this earlier, I was like, oh, I'll point to this. That's okay. So if you look down here, we have on the far left here, we have a number of different factors that contribute to high tide flooding. So there's a typical tidal range, so the difference between your typical highest tide and your typical lowest tide, and that's sort of what we have on average. But then seasonally, there are certain times of the year when the tides are higher than others. Then we have obviously a contribution from sea level rise. And then there are other things going on in the ocean, like maybe just the Central Pacific. Like for this particular event here from August 2017, we had a number of factors adding up. And so one of the factors was the fact that the Central Pacific was just warmer than typical. When the water is warmer, it takes up more space. Sea level is higher, and so that adds a good bit of extra sea level rise on top of our other factors. Ocean turbulence, things like ocean eddies. Sometimes those eddies have warm cores that can have a high sea level signature associated with that if it impinges on the island. Air pressure effects, all these different factors. And so really what we end up with is a confluence of many things happening at the same time that can lead to these high tide flooding events. So it's not just the king tide, although it's important. It's also these other oceanographic factors on top of it. But as we go into the future, more and more of just the regular old king tides will begin to cause these sorts of impacts. Okay, next slide. So now we have what it is, what causes it. So how often is this occurring? Well, that depends somewhat on your definition of what the flooding threshold is. How high does the water need to be in order to cause high tide flooding? And this is where the King Tide Project really is important, especially for scientists and researchers, because this allows us to, if you go out and take a photo, we can look at the timestamp of that photo and compare that to our observations of the water level. And we can say, oh, well, this level of impact is occurring at this time when the water was this high. And so we can kind of get an idea of important thresholds based on this work. So it's really important, and we really appreciate that project. So here, there's this blue line here that's hashing all over the place. This is water level from Honolulu Harbor every hour since 1914, since the early 20th century. It's a really great record, one of the best we have in the world. And this black dashed line above it, that's at about 14 inches above the typical highest tide of the day. And that threshold is roughly based on sort of what we know from impacts around the state, including looking at the photos from the King Tides Project. And so if you look at how many times that threshold gets exceeded, so that's what I've done here in the bottom. On the bottom, we're counting each bar as a count of number of days per year that the threshold gets exceeded in time. And you see that early in the 20th century, there are no exceedances. We haven't had any. And as we move further into later in the century, you may have one, maybe two, at most three per year in just a handful of years. But then over the last 5 years or so, you can see much higher numbers. And in fact, in 2020, we set a record for 18 days above this threshold. And you can see the impact of this in that blue curve. It's a little subtle because of all the other things going on, but that general rise of sea level rise going on within that blue curve, slowly pushing more and more and more of those hourly water levels above the threshold. And that's what we expect to see more of in the future. So right now, at most probably 15 or 20 days per year in a bad year, which is what we had in 2020. Okay, next slide. So then, what do we expect to see in the future? There are a lot of other natural cycles that are interacting with climate change and sea level rise that can cause interesting things to happen with the number of these events as we look forward into the future. And in fact, these natural cycles, adding on to our climate trends, can lead to periods of rapid change and periods of very little change. And so what I'm showing here in this figure, on the vertical axis on the left side, that's the number of days per year we expect to exceed that threshold we talked about 14 inches above average highest tide of the day, where we start to see these minor flooding impacts. And then this black curve is our best estimate of how many times per year we expect to see that exceeded. And what you see is that from present out to around the mid-2020s, you have a fairly rapid increase up to about 20 per year, which is what we experienced in 2020. And then a flattening of that. So we don't expect to see a whole lot of change from the mid-2020s to the mid-2030s. But then there's a tipping point around the mid-2030s in which this really takes off. And this is due to natural cycles in the tides combined with the climate change signal, the sea level rise itself. So that mid-2030s is a really important tipping point for Hawaii, for the whole state. Next slide, please. And I like this Hawaiian proverb that I think fits really well here. Ikehiki ka'ua ako e kahale. While the rain is far away, that's the house. And so that mid-2030s point there, we should have our thatching secure by then, before this really takes off. And it's not sufficient to wait. So if we get to mid-2020s, we won't see a whole lot of change potentially for the next decade. And so that's not a reason to be complacent, because we know, in fact, that there are natural cycles that are suppressing our impacts during that period. We need to be aware that the switch will flip around the mid-2030s most likely. And that's the point in time where we can't wait until that starts to happen before we start to make these major infrastructure improvements around our state, not just with cesspools, with other things as well, drainage systems, et cetera. And then at that point, we need to be prepared for some rapid changes. Next slide. How am I doing on time?
You're doing good. You have 2 more minutes.
Oh, perfect.
Also 5 minutes for Q&A.
Okay, great. So this is just another way to look at that same idea, except we tried to simplify it a little bit and bin it into decades. So let's look at the difference between what we expect for the rest of this decade versus the 2030s versus the 2040s, based on a particular scenario of sea level rise where we get about 1 meter by the end of the century. Certainly plausible. Potentially we could get more, but this is a very plausible scenario. And in that case, we're looking at by the 2030s anyway, let's start there. We could potentially be starting to see around 50 per year of these events, potentially, under this scenario. But you'll see that big jump to the 2040s. So I'm talking about the dark orange, the darker squares here. Those are for the average number you expect to see in each year for each of these decades. So if you averaged all the years, something like 50 per year. And we expect that to quadruple under this scenario from the 2030s to the 2040s, a massive change. And then if you look at the light boxes, those light boxes correspond to the worst year in each decade. So we started looking at what's going on now, how you might have, a really bad year, and then you might have a few years of nothing, and then you might have another year in which many of these events cluster together. So those light boxes represent what you expect in the worst year of each decade. And we're looking at the 2030s of potentially under this scenario having a year in which we get more than 100 days of this in 1 year in the 2030s. That's not that long from now. So these changes could potentially happen very quickly, and we need to be prepared for them. So that's all I had, and I'm happy to discuss with you all more and take some questions.
So Phil, we have one question in the chat, which is asking about American Samoa. And do you think American Samoa can expect to see a similar timeline?
American Samoa is a different case for a couple of reasons. One of them is that those natural cycles that we talked about, the ones that causes sort of this rapid and then a flattening and then another rapid increase, that cycle is less important in American Samoa. So that cycle that we're looking at for Honolulu is associated with an 18.6 year cycle in tides. In American Samoa, there's a greater influence of a 4.4 year cycle. So you'll actually have more variance over sort of a shorter time period in the number of events in American Samoa than you would in this curve in Hawaii. The other major difference, which is more important, is that American Samoa is sinking. due to the 2009 Samoan earthquake. And you can expect to see potentially twice as much sea level rise relative to the land right now in American Samoa compared to other places along in the Pacific region by the mid-century, by 2060 or so. So there is a lot of concern in American Samoa, and actually the projections that we currently have are not adequate to both to look at that subsidence plus the climate change, and actually that's something that my group at UH, funded by Darren Lerner's group, PICASC, and working with people in Sea Grant as well, Kelly Tagarino in American Samoa, we're going to be looking at that issue over the next couple of years with the project.
Great. Thanks, Phil. The next question is, why are there periods of slow change and periods of rapid change? What leads to the inflection point?
Yeah, I kind of was a bit flippant in that description, but we can be a little more precise if you like. So like I said, there's natural cycles in tidal range. So if you think about the lowest tide of the day and the highest tide of the day, something we're intimately familiar with is how that changes on like the lunar cycle. So new moon to full moon, right? When we have that maximum tidal range, and then the quarter moon when we have a smaller tidal range on a monthly basis. But there are similar changes in the alignment of the Earth and Moon, particularly how the angle of the Moon is relative to the equator, that happen on different timescales. So that same squashing and increasing of the tidal range happens over 18.6 year cycles, not just a monthly cycle in some places of the world, this part of the Pacific being one of them. And so what's happening is that during those periods when things are increasing quickly, not only is the average level going up, but the tidal range is increasing as well. And then the periods where there's not much change, you have sea level rise is still happening in the background. It's still pushing it up, but at the same time, the tidal range is squashing. And so the overall impact on those highest tides is canceling out. So those long-term cycles are canceling out some of the impact of the sea level rise on the height of the highest tide. So you have periods when the tidal cycles are amplifying the effects of sea level rise, and then periods when it's decreasing the effect of sea level rise, and then amplifying again. And that leads to those periods of increase, flattening, and then increase again.
Okay. And then we have a couple of questions about the timing of those cycles you're talking about. One is, what is the level of confidence that this cycle is in a longer timeline, say 500 versus 100?
Yeah, well, so tides is one of the things that we do, we know very well, because the orbits and even the very complicated motions of, which can be very complicated to actually describe, is regular. It's highly predictable. And so if I take my tidal measurements from Honolulu Harbor, the astronomical part of that, the part that's related to the Earth, Sun, and Moon and how they relate to each other, their geometry, I can project that part of the water level out to 100 years in the future and be really confident that that's exactly we're very close to what it will be. So yeah, so we're pretty confident in that part of the cycle. There are other things going on in the climate system, of course, that are less confident, but that part, that 18.6 year cycle, we're very confident in.
Thank you, Phil. So I think that's all the time we're going to have for questions for Phil, but I will direct Phil, if you have a minute to respond. Kelly has a question about the 4-year cycle in American Samoa that maybe you could respond to in the chat for her.
Sure.
Anyone has lingering questions for Phil, feel free to put them in the chat, and maybe he can do his best to answer there. And we'll move on to hear from Shelley.
Yeah, hey everybody. Sorry, I had to turn off my camera. I'm having internet issues as always. Yeah, thanks Phil for that really good talk, really good information. And thank you all for being here and for your interest in this topic. I'm Shelley Habel. I work as an extension agent and coastal geologist for UH Grant, where I'm seconded or commissioned to the state DLNR Office of Conservation and Coastal Lands. There I work on issues of coastal erosion and other coastal impacts impacting our state. Also, as part of my doctoral research, I worked in Dr. Chip Fletcher's lab, which is the UH Coastal Geology Group, where my main focus was to produce map simulations of sea level rise induced flooding caused by groundwater. And we continue to evolve this research in collaboration with the Honolulu Board of Water Supply. So today I'll go over impacts of sea level rise on on-site sewage disposal systems, owing to both erosion and groundwater inundation of those systems. Okay, next slide. So you might be all caught up on this introductory information, but I'll just go over it to provide some context. Among the islands, groundwater mainly exists as part of a freshwater lens aquifer, where freshwater percolates to the ocean under the force of gravity. And because freshwater is less dense than saltwater, it floats on top of salty ocean water. And a large portion of our wastewater infrastructure is made up of on-site sewage disposal systems, or OSDS, many of which are cesspools. And these dispose of sewage and other types of wastewater underground, with the idea being that the material is filtered by natural processes before it reaches drinking water wells or the ocean. Next slide. So cesspools, which are one of the main styles of OSDS, is described here. This is from the State Wastewater Program website. So according to the State Department of Health, cesspools are little more than holes in the ground that discharge raw, untreated human waste. Cesspools can contaminate groundwater, drinking water sources, streams, and oceans with disease-causing pathogens, algae-causing nutrients, and other harmful substances. Untreated wastewater from cesspools contains pathogens such as bacteria, protozoa, and viruses that cause gastroenteritis, Hep A, conjunctivitis, leptospirosis, salmonellosis, and cholera. Next slide. It's been estimated by researchers with Department of Health that more than 110,000 active OSDS exist statewide, in which 1,853 are cesspools located within 200 feet of shoreline, which by themselves result in 1.7 million gallons of cesspool wastewater to be released within that 200 feet of shoreline per day. In 2016, there was a ban on the construction of new cesspools, but active cesspools remain in use. Next slide. So here's a GIS map showing approximate OSDS locations on Oahu. And you can see that a really disturbing amount of these are located along the coastline. Next slide. Okay, here's a similar map of Maui. Next slide is a similar map of Hawaii. And these resources have also been produced for Molokai and the Big Island. These OSDS maps they're hosted on the state's state GIS web portal. Next slide. So yeah, as Phil was mentioning, sea level is rising. These measurements are from the Honolulu tide gauge that show it rising steadily over the course of a century. And this rate is expected to accelerate, which will exacerbate problems related to OSDS. Next slide. The fourth National Climate Assessment has assigned high confidence to sea level magnitudes reaching between 0.15 and 0.37 meters by 2050, and between 0.3 and 1.3 meters by 2100. However, emerging science on Antarctica suggests that it's physically possible that sea level may exceed 2.5 meters by 2100 under high emission scenarios. Next slide. So at this point, coastal hazards, which are exacerbated by sea level rise, have begun to impact cesspools and other types of OSDS. Main coastal hazards impacting these are erosion and groundwater inundation. Next slide. So these are images that my colleagues and myself have taken over the years of OSDS located precariously close to the shoreline or directly on the shoreline. So There's an arbitrary 50-foot setback required for installation of OSDS. If closer to the shoreline than that, then the project requires a variance in which more sophisticated OSDS systems are required that provide a higher level of treatment. But know that even the more sophisticated systems still require leach fields. And besides being arbitrary, there's another problem with relying on this setback to make sure that wastewater doesn't contaminate the shoreline. That's that the distance between the shoreline and OSDS decreases as the shoreline moves landward by erosion, such that eventually they can end up very near to the shoreline or directly on that public beach. Next slide. So I'm going to use North Shore Oahu to illustrate this problem more clearly. The blue dots here are cesspools located near the Camis and Sunset area in the map on the right. Next slide. This area, it naturally experiences some of the world's largest waves. And on top of that, houses in the backshore, they're sited on large sand berms, which are known to be transient geologically. They shift around. So this is really devastating for homeowners, but it's not surprising that, sorry, I'm getting phone calls here. It's not surprising that erosion threatens backshore infrastructure in this area, including both houses and the buried wastewater infrastructure that are associated with them. Further, if you take a look at how erosion is projected to impact the site according to the State SeaLevel Rise viewer, next slide. It's evident that homes, in addition to their buried wastewater infrastructure, will be directly impacted by erosion over the coming decades. And you might say to yourself that like this is just one heavily impacted area, but the reality is that a lot of these rural locations are not served by municipal sewage treatment. So the issue you see here is one that exists along very extensive lengths of shoreline. Next slide. And the other issue I want to hit on is groundwater inundation. In very low-lying places, groundwater is near to the surface of the ground such that you can dig a hole and find it within several feet or even a couple feet of the ground surface. Groundwater, it goes up and down with the tides, anomalous sea levels, rainfall events, etc. These photos here show archaeological and construction excavation sites in Western Waikiki that shows that groundwater is very near to the ground surface such that you can envision issues we'll be up against as sea level continues to rise. Basically, we're going to have flooding coming up and through the surface of the ground, which will flood underground assets and infrastructure even before floodwater reaches the surface. Next slide. As sea level rises, groundwater will be lifted, forming inland urban wetlands. Next slide. And it's already causing damage to underground infrastructure in Honolulu. This is a basement located at the Honolulu Police Station on Veritania, about half a mile from the coastline. So just as a side note, sea level rise related flooding will not be, and it is currently not limited to areas directly next to the shore. Next slide. So as part of my doctoral research, I mapped areas of future groundwater inundation by simulating water table elevations, considering present sea level, incremental increases in sea level, and tidal influence. By comparing those water table elevations with ground elevation data, I was able to make maps showing locations of expected inundation in areas with extremely narrow distances between the ground and groundwater, which we call unsaturated space. Next slide. And we compared these results to OSDS GIS data from the Department of Health, in which we look primarily at cesspools. So the triangles here show where active cesspools have likely exist. They've been flagged by DOH. And the Department of Health considers cesspools effective when they have 15 feet or more space between the ground and groundwater, because it's assumed that treatment has occurred by that wastewater filtering through the soil, that dry soil space. Blue triangles here show cesspool locations that currently have that 15 feet. Yellow triangles show cesspools that don't meet that criteria, either because there's not enough unsaturated space between groundwater and the base of the cesspool, or because the cesspool is partially inundated. And the red triangles show where cesspools have been fully inundated from top to bottom and are considered to be releasing wastewater to the ground surface. And again, this map, it shows current conditions. So in Honolulu, very close to 90% of cesspools are considered compromised. Next slide. Okay, I'm going to show you some simulations of sea level rise induced groundwater inundation and cesspool failure. So this is about a foot of sea level rise. Next slide. About 2 feet. Next slide. 3 feet. Next slide. 4 feet, and next slide. That's 5 feet. So going forward in time, you can see cesspools go from compromised to fully flooded, where it'd be likely that contamination at the surface of the ground would occur. The areas in blue show where groundwater inundation is occurring above the ground surface. Yellow areas show where groundwater is really shallow, about a foot below the ground, which highlights areas vulnerable to flooding during rainfall events and flooding of underground infrastructure like basements. So it's one thing to run models and simulate these issues, which highlight the potential for increased contamination, particularly in areas frequented by us, the public, and it's another to confirm it. Next slide. So earlier this year, my colleague, Dr. Trista McKenzie, visited one of the sites where our models indicated that groundwater inundation is currently happening. It's Mapunapuna. And Trista used various geochemical tracers to indicate that flooded areas are experiencing pulses of groundwater into those floodwaters at high tide. And further, that those pulses bring with them wastewater from compromised treatment systems. Next slide. So I really encourage you to read this paper. It's really eye-opening, but in short, what Trista confirmed is that wastewater infrastructure is indeed compromised. Groundwater inundation is already happening, and that wastewater leakage to shorelines and the ground surface is already a problem, which we can expect to worsen as sea level continues to rise. So these are all really wicked issues. I just wanted to give you guys an idea of the problems that we've identified so that we can move forward with the next step of developing solutions to these problems. And that's all I have for you today, but with that, I can answer any of your questions. And after that, I'll pass it to Yoko to talk about some developments on this front.
Thanks, Shelley. Yes, so please put your questions for Shelley in the chat. We have a long one to start us out from Kelly Anderson Tagarino. She says your groundwater images made her wonder if the increased cost of construction work in tidally influenced areas, i.e. when they dig down and hit water at high tide, has been noticed by the construction industry. And if the construction industry has access to such groundwater flooding or water table info at a fine enough resolution that the company could include the increased cost of their work in their bids? And if so, has this driven any change in siting or locations of buildings and OSDS? And you can look at the chat if you need to get a handle on that.
That's a really good question. Yeah, so yes, that's pretty common actually when they're working in really low-lying areas, that when they dig construction trenches, they have to de-water. So they have to use pumps and actually de-water that site. Yeah, and it's amazing to see these.
At the start?
What's at the start? Yeah, before. Yeah, I think one of the first, I'm not an engineer or contractor or anything, but I think one of the first steps on site is to go ahead and excavate those construction trenches. They hit groundwater, and then they have to dewater the pit. And actually that dewatering, it is known to cause, it can cause destabilization of structures nearby. And I think one of the things that they were looking at with the Miami-Dade collapse was there was a building that was built a couple properties down just like a few years ago. And when they were doing construction at that site, I think they had to do a lot of dewatering, which causes changes in the underlying soil and can cause foundation problems. And those issues, I think when they were doing construction with the international marketplace, they had to dewater a lot, and it was noted to perhaps cause structural issues nearby. Yeah, so it's a thing that contractors worry about and engineers worry about.
I'll probably circle back with you later on about that, because here it seems like they just start the work and then go, oh, we can only do this work at low tide with dewatering, with hole holders. And then it's just, extends these projects for so long and increases the price so much that, just leads to a lot of issues. And we have a lot of planned construction coming up. So I'd be curious about how this works. So I'll connect with you later about that.
Okay, yeah, please do.
Thanks.
Okay, so we have a couple questions coming in from the chat, some of which I think Yoko is going to address in his next presentation. So feel free to punt any of these, Shelley.
Okay.
But we have a question from Rob Poro. How has this research been received by government agencies, particularly Board of Water Supply and Department of Health? Has this sparked any efforts to change policies related to OSDS?
Yeah, I think that it has, like we have done we've done a lot of outreach and presentations and stuff to Board of Water Supply and Department of Health. Not to like Department of Health or Board of Water Supply is one of our major funders for this, for both my doctoral research and ongoing research to install a groundwater monitoring system across the Honolulu area. So Board of Water Supply is very interested in these issues. Yeah, so yeah, it is spurring a lot of conversation with groups like BI and the Water Resource Research Center and others. Yeah, those conversations have definitely started.
Okay, and one more question for you, Shelley. Is there a rule of thumb for how many times a cesspool can be flooded before it becomes a major issue, or is even one time too many?
I don't know about any of those standards. I know of cesspools near the coastline where you can lift up the lid and watch the tide go up and down. And so, yeah, I think some of these cesspools are flooded kind of all the time. Yeah, so those standards, they haven't been written yet, is my understanding.
Okay, and then we have a question from Lupita, which I'm going to use to transition us to Yoko because it's a perfect transition. She's asking, what types of ideas do you have for getting support or funding to remove cesspools in a timely manner? And I think Yoko is going to speak just to that. So if you have additional questions for Shelley, please feel free to enter them in the chat and she can help answer them there. And we'll move on to hear from Yoko.
Thank you. Hey, everybody. Thanks for joining, and thanks to my co-presenters. Great job, though. Super interesting. I represent not only Sea Grant as a GRAW Fellow, but also the nonprofit VI, which stands not only for the Hawaiian word for clean water, but also for wastewater alternatives and innovations. And we like to use this photo that was taken for a PSA to show that cesspools near the shore are as gross of a concept as toilets would be on the beach. You wouldn't want that. So we also don't want cesspools near the shoreline. So go ahead and go to the next slide. Thank you. Shelley touched on this a little bit, but I wanted to talk about the recent history about why people are talking about cesspools now more than they were 5 to 10 years ago. The legislative mandates about cesspools are ramping up, luckily, starting with in 2006, the EPA banning large capacity cesspools. That means in Hawaii, any houses or commercial businesses producing more than the equivalent of 5 bedrooms of wastewater into a cesspool, that's considered large capacity, and those have been illegal since 2006. There's still some around, but every time one is discovered, it's sort of big news and the people get in trouble and you have to convert it. Regular cesspools, meaning 5 bedrooms or less, are now being tackled by Hawaii. And it started in 2015 when Act 120 was passed, where, like Shelley mentioned, new cesspools were forbidden, and there was a tax credit established to upgrade systems. It was hardly used because it wasn't really consumer friendly, but we're working on a better version to come soon. Act 125, passed in 2017, mandated the upgrade of all cesspools in the state of Hawaii, all 88,000 of them, by 2050, and required DOH to complete a prioritization. And Act 132 created the cesspool conversion working group, in which my boss Stuart is a member, where essentially the biggest stakeholders in Hawaii are coming together to discuss this topic. Next slide, please. I'm sure almost everybody here knows the difference, but I still like to show it to everybody what the difference between a cesspool and a septic tank is. And the picture on the left was created by good friend and collaborator, Michael Mezzacapo. So the left, you can see a cross section of a cesspool, which is essentially really just a hole in the ground. It receives all untreated wastewater from all parts of the house, kitchen, bathroom, laundry, and it seeps into the depth of the cesspool. You have cesspools usually between 6 and 8 feet in diameter and between 5 and 100 feet deep. Most of them are around 15 feet though. And the liquids and some of the solids seep out into the surrounding soil. Most of the solids stay in there though. That's why you have people pump their cesspools, because they fill up with toilet paper, poop, food scraps. And the rest goes into the surrounding ground, and oftentimes groundwater is not far away if it's not already inside of the cesspool. And you can see the pathogens and the nutrients go straight into the groundwater, polluting the streams and drinking water wells and the ocean. It's really bad. There's no treatment happening there. A septic tank, on the other hand, you can see on the right, is an enclosed tank with an inlet pipe and an outlet pipe, and it produces some sort of treatment. It's gravity, it's no electricity, just settles the heavy particles to the ground, and the liquids continue out to some sort of dispersal system, for example, a leach field. It's really important to note that septic tanks, while being a lot better than cesspools, are still not the be all end all. They don't filter out nutrients, they don't filter out pathogens. And so we don't want to say septic tanks are the solution. We'll get to more of that later. You can go to the next slide. Cesspools, and in some regards, septic systems, pose a lot of health and environmental risks and hazards. They pollute drinking water, which in Hawaii, 95% of drinking water comes from the ground. They increase pathogen loading in the water, and that can lead to disease. And on the environmental side, the nutrients create algae growth where there's not supposed to be that much algae. And the sewage pollution can really damage the coral, and our pristine ecosystems deserve better than that. You can go to the next page. Here is an image showing approximately the locations of the cesspools in 4 of our islands. You can see not only are they going from Mauka to Makai, but they are in urban areas, in rural areas, and in between. It's a problem that goes through all to all socioeconomic layers, and it's our collective responsibility to tackle this problem. And the yellow areas are the prioritization areas defined by the Department of Health, which are being reworked and investigated further at the moment. You can go to the next slide. Why is it important that we have clean water? Well, it's a question that has many answers. Quality of life and swimming, reefs are important, biodiversity is important, food resources. There are tons of answers why we want clean water, but also the money side. The coral reefs have been valued at billions and billions of dollars. The healthy reefs are important for tourism, and clean, unpolluted waters is what people think about when they think of Hawaii, and we don't want that to change. You can go to the next slide. So what are the solutions? We think that there's 4 real good ways in the tech side to tackle this. We can expand sewer, municipal sewer or private sewer where that is already existing, or build new sewage treatment plants. That is not the solution for everywhere. It's the solution for urban areas, oftentimes, but it's very expensive and it's very slow. What you can do is have better performing individual wastewater systems. Individual wastewater system meaning the wastewater is treated and disposed of on the same property where it is created. So septic systems, for example, aerobic systems, or systems that we'll get to in a second count as individual wastewater systems. And decentralized wastewater treatment circular economy, that's something that we like to refer to as community scale or cluster systems, where it's not quite the scale of municipal sewer of thousands of homes. It's not the scale of just one home, but it's somewhere in between. It's like 20 houses, 100 houses. That's a pretty good scale to introduce these community scale systems that are gaining ground. And lastly, innovative toilet technology. Some toilets treat the waste right while you sit on the toilet, and they don't even produce any liquid or solid effluent. And that's really exciting too. So let's go through them. Next slide, please. This here is a Cinderella incineration toilet. And it really does what you think it does. It incinerates your pee and your poo. So you do your business and you press a button and the liquid is evaporated and the solids are turned into ash. That reduces the volume, meaning you only have to empty the ash bowl once a week for a family of 4. And it also means that you don't have to have any water line, any sewer line connected to this. It's a cool little system that has many applications, not only in rural outhouses, but also campgrounds, or if you just want to add a bathroom and you don't want to have sewer line and water lines set up. We have some of these in the ground, and I'm proud to say that Bai is the representative of Cinderella in the state of Hawaii. Next slide, please. Here are 3 examples of individual wastewater systems that are better, much better than septic systems. You have biofilters, which are essentially a septic tank plus a leach field that is sort of an improved leach field because it produces better bacteria that's able to treat wastewater to a higher standard by means of wood chips and biochar and all kinds of cool nature-based materials that can be sourced locally. On the bottom, you can see constructed wetlands that use a combination of plants and bacteria, just like a natural wetland would, to treat wastewater before it's being discharged somewhere else. And on the top right, you have aerobic treatment units that are similar to septic tanks, but they have added electricity powered elements that produce diffused oxygen for aerobic bacteria as well to live in and clean the water better for disposal in, for example, a leach field. Go to the next slide. And then going to a decentralized system, you have companies like Cambrian who are able to treat community scale wastewater and do it in a way that's even economically feasible for them because they take the energy, they convert it to energy and they convert the liquids to reusable water, for example, for irrigation. So everybody wins. There's money being made and the waste is not wasted. You can go to the next slide. So all in all, what does this mean? Well, in Hawaii, we have a problem with cesspools and we can tackle it together and turn it into an opportunity. Meaning if we decide together to leapfrog past just converting every cesspool into a septic system, which is only a very, very short-term solution that doesn't improve the situation much, we can instead jump to much better technologies and turn this crisis into an opportunity and protect our ecosystems and our fellow Hawaiians and Hawaii residents. You can go to the next slide, the last slide, I think. So if y'all want to learn more, we just rolled out a few days ago our potty portal, which is a one-stop shop for information on cesspools in Hawaii. You can find it at vicleanwater.org/potty portal. It has a map of all cesspools, an interactive map where you can enter an address and you can see if there's most likely a cesspool there or not. You have information about different systems, information about what kind of system is best for certain properties, information about laws, and information about lots of things that I just talked about. So feel free to check it out. I'd be happy to answer any questions you have. Thank you very much.
Thanks, Yoko. So we have a couple of questions coming into the chat. One of them is about cost. So if you could explain a little bit more about the cost of these innovative technologies versus septic systems.
Yeah, absolutely. So as an engineer, it's always tough to give cost estimates because it's so site specific, but I'll do my best. So for an average septic system, an upgrade of a cesspool to a septic system, which again, is not what you want a lot of the time. It's between $20,000 and $50,000, including permitting, labor, materials in the state of Hawaii. So that being the baseline, say average $35,000, you have to add a little bit extra for these innovative systems most of the time. We are working on systems that are going to be cheaper than that, and we are having some pilots in the ground, which we're really excited about. But right now, that's what you're looking at. It's approximately $35,000 per system. Sometimes cheaper, sometimes more expensive.
Okay, and I'll just note that we will end the session at 1 o'clock, but if folks want to stay on with additional questions, they're welcome to do that. I have a question that I might want to ask. I was wondering if you could, it sounds like this is a little bit in flux, but if you could talk about, oh wait, okay, we'll prioritize the questions from the actual participants, not me. Constructed wetlands seem like they would be a poor choice in a heavy rainfall or flood prone areas. What would you recommend for these areas?
Yeah, for those areas, you could go with a bunch of different options. For example, an aerobic treatment unit would work really well because that's doing the treatment underground. There's no inflow or infiltration of rain. But I will say constructed wetlands, if you want to, break one of those, you need a lot of rain. So I think even in rainy areas, constructed wetlands often work pretty well, depending on the type of constructed wetland you go with. I would say if you are careful with directing your slope, making sure if you have overland flow of rainwater, for example, that doesn't all just go directly into the constructed wetland, you can do a lot of work with that. And yeah, otherwise aerobic treatment units are a great choice.
Thanks, Yoko. Okay, I guess one last question, which is my question that I'm going to sneak in. You talked a little bit at the top about some past programs to provide financial assistance to people who need to upgrade their on-site sewage disposal systems. Where are we in the policy process around that, and kind of what are the plans moving forward to provide financial assistance to these conversions?
Yeah, great question. Like I said, unfortunately, the tax credit program wasn't that huge of a success, but we're doing a different approach now where we're trying to help the counties leverage state revolving funds, clean water state revolving funds. That is federal money that then goes to the state, then goes to the counties, and we're trying to help them work a way where they can then give the county money to individual homeowners to upgrade. And it's still in the beginning, it's not existing yet, and we're working very hard to help the counties make that happen. Other than that, there are USDA loans and grants that are available to certain homeowners. There are county loans that are available. And please hit us up at info@vicleanwater.org, and we can help you on an individual basis.
Wonderful. Thank you so much, Yoko. So that brings us right to 1 p.m. Thank you all for joining us. We really appreciate your interest in this topic. And please feel free to stay on if you have individual questions. But otherwise, we hope you have a great rest of your day. And take some King Tides photos, please.